Welcome to the deep dive. We are diving deep today into the Portwell Engineer Toolkit, specifically version 2.15 from December 2023.
Right.
Basically, think of this as like getting the cheat codes
Right.
for understanding and controlling Portwell embedded systems.
Yeah.
If you're working with Portwell hardware, this is really going to break things down for you.
Absolutely.
So what do we have here? What is our source material today?
Yeah. So we have what appears to be the user manual for this toolkit.
Okay.
And it's a very substantial document.
Okay.
It's got everything from like the initial version all the way to the very latest features.
Yeah.
We've got version history.
Yeah.
We've got an overview of the toolkit.
Okay.
Environment, installation details,
Right.
prerequisite knowledge,
Yeah.
all kinds of information on the Portwell engineering tool, utility,
Okay.
extensive documentation for the PE library, including a function list,
All right.
introductions to every single function, prototypes, parameters, return values, sample code,
Wow.
and then an FAQ section.
So really, really thorough documentation.
Yeah, very thorough.
Yeah. So this is like a treasure trove of information.
It is.
And our aim here today is to sort of extract the gold nuggets
Yes.
for you, the learner.
Right.
And by that, I mean to try to really distill down what are the key aspects of this toolkit.
Yeah.
So that you can understand what it offers, if it's something that would be relevant to your work,
Right.
and hopefully all without getting too bogged down
Exactly.
in the technical details.
Yeah, we're going to try to make this approachable.
Exactly.
Not get too deep into the weeds.
Yeah. So we're after the aha moments
Yeah, the big picture.
and the practical implications.
Right.
So let's start at the beginning.
Okay.
And I think a good place to start with any sort of technology
Sure.
is to look back and see how it's evolved over time.
Yeah, look at the history.
So the version history here really sets the stage
It does.
for what we're looking at.
It really does.
And it stretches all the way back to January 2011,
Wow.
with Robert credited as the original author.
So over a decade of development.
That's incredible.
That's a lot.
So right away, that tells us that this is something that's been very rigorously
Right.
tested and improved upon over a very long period of time.
Absolutely.
This isn't some fly-by-night software.
Yeah, no flash in the pan here.
And what I think is interesting
Let's
is
see.
if we look at some of the key milestones here and the individuals who are behind them,
Right.
it looks like Robert's initial focus was really on those core hardware interfaces,
Let's lay the foundation.
like the watchdog timer, SMBus, GPIO.
Right.
So these are fundamental building blocks for interacting with the hardware.
Absolutely.
And then, about a year later, we see Angela stepping in,
Okay.
adding support for the SMBus protocol,
Right.
but maybe even more significantly,
Yeah.
introducing the Portwell engineering tool utility. And this, I think, is where things start to get interesting because it suggests that there was a move to make this more user-friendly,
Absolutely.
to offer a more visual way to interact with the hardware,
Right.
in addition to the code libraries.
Yeah, a GUI for people who don't want to get into the code.
Exactly.
Yeah.
And then we see Jesse
Yeah.
stepping in around 2019,
Okay.
bringing a new wave of updates.
It looks like Jesse really focused on modernizing the toolkit.
Yeah.
So we see in 2020 Windows 10 support, followed up in 2021 by Windows 11 support.
Okay.
Significant updates to the PT utility,
All right.
and crucially, new hardware monitoring functions, right?
Right.
So temperature readings were added.
Yeah, so getting into more than just basic I/O.
Right, starting to get into the health of the system.
Exactly.
And then just last year, 2023, we got the addition of smart fan control, net bypass for network redundancy,
Okay.
LED control.
So they're constantly evolving,
Yeah, always adding features.
keeping pace with new hardware and user needs.
That's right.
So, I mean, if we just step back for a second
Yeah.
and look at this history,
Right.
we've got a long history.
Yeah.
We've got multiple engineers contributing over more than a decade.
Absolutely.
This tells a really, really clear story, I think,
It does.
about Portwell's commitment
Yeah.
to their embedded hardware platforms.
They're not just releasing this hardware and saying good luck.
Right.
They're providing tools to make your life easier.
Exactly. It's not just like, here's the hardware, figure it out.
Yeah, figure it out yourself.
You're on your own.
No, they're trying to help you
Yeah.
make things easier for you.
So that brings us to the core question.
Okay.
What exactly is the Portwell Engineering Toolkit, or PT?
That's the big question, right?
Yeah.
We've seen the who, we've seen the when. Now let's look at the what.
What exactly is this thing?
Yeah.
What is this thing called PT?
Yeah. So at its heart, PET is a collection of APIs,
Okay.
application programming interfaces.
Okay.
Think of these as sets of pre-written code
Okay.
that act as intermediaries.
Okay.
So your software can communicate with and control the Portwell hardware in your embedded system
Right.
without needing to speak directly
Right.
in the language of the hardware itself.
Right.
Because that can get very complicated.
There's like a translator
Yeah, it's a
between your software
Right.
and the hardware.
Yeah.
So your software wants to do something, maybe wants to change a setting,
Right.
adjust something,
Right.
and PT provides the way to make that happen.
That's right.
Without having to...
Without having to know all the low-level details of the chipset.
Exactly.
Or the drivers or anything like that.
Yeah, it's like a universal remote.
Yeah, like a universal remote.
For your Portwell hardware.
Perfect analogy.
So instead of needing to understand all the really intricate details, you can use these ready-made functions to do what you need to do.
Achieve your goals.
And the documentation lists a bunch of benefits to using this approach.
Right.
And the first one is faster time to market.
Yeah, which is huge, right?
Huge.
Especially in the embedded world.
So how exactly does using PT lead to a faster time to market?
So you're not reinventing the wheel, right?
Right.
Developers can use these ready-made APIs to write applications that control hardware much more quickly.
Right.
You don't need to spend time developing your own low-level interfaces for common tasks.
Right.
Like communicating with onboard components.
Yeah, it's like having a well-stocked pantry when you're cooking a meal.
Exactly. You have all the ingredients.
Yeah, you've got everything you need.
You don't have to start from scratch.
Exactly.
You can
Pull
just
it all together.
Put it all together. The second benefit is reduced development effort.
Right.
So how does PKey save developers?
So imagine you need to communicate with an onboard bus.
Okay.
Like SMBus.
Okay.
Which is often used for managing power components.
Okay.
Without P.
Yeah.
You might have to write that code yourself.
Yeah.
But PT gives you those functions.
Right.
That abstract away all of that complexity.
So you're saving time and effort.
Yeah, a significant amount.
The third one is enhanced reliability.
Okay.
How does using PET?
So because these APIs are provided by Portwell, we can assume that they've been rigorously tested.
Okay.
So by using these functions, you know, they've probably been used and validated across various platforms.
So you're not going to introduce bugs.
Yeah, you're reducing the chances of that.
Compared to writing your own code.
Absolutely.
And the analogy they use is it's like choosing a professionally built bridge.
Right.
Versus building one yourself.
Yeah, don't build your own bridge.
If you don't have any engineering experience, don't do that.
The fourth benefit is flexible upgrades.
Okay.
How does PT make it easier?
So as Portwell introduces new hardware, they can update the PT toolkit to support those features.
Okay.
So as a customer, you might be able to just update your PT version and get access to those new features.
And not have to rewrite a bunch of code.
Right, exactly.
Right. That would be huge.
That would save so much time.
And then the final benefit is board testing and verification.
Right.
So how does PT help you?
So PT provides all these functions to interact with various onboard components.
Okay.
Things like checking the status of GPIO pins or reading sensor data.
Okay.
So it allows for quick and easy testing of all those functionality.
So you know it's working right out of the box.
Exactly.
So we've talked about sort of why you would want to use PT.
Yeah.
And the advantages. Now let's get into the nitty-gritty.
Okay.
What can you actually control with this toolkit?
Yeah. What can you do with it?
What are the key capabilities?
All right, so the documentation outlines several major functional areas.
Okay.
Which we can think of as like a menu of possibilities.
Okay, so like a high-level overview.
Exactly.
What T can do.
So the first one is board information.
Okay.
This allows your software to query the system and get details like the BIOS version.
Okay.
The specific model name of the board.
All right.
And the firmware version of the embedded controller.
Okay, and the embedded controller, just so we're all on the same page.
Yeah.
Is that like a separate little chip?
Yes. It's a dedicated microcontroller.
On the board.
On the board.
Okay.
That handles various low-level tasks.
Okay, got it.
And so this board information can be really useful for system identification, logging diagnostics.
Okay, cool.
Just kind of getting a sense of what you're working with.
Next up is GPIO port control.
Okay.
Now, for someone who might not be deeply familiar with hardware.
Right. What exactly is GPIO?
GPIO stands for General Purpose Input-Output.
Okay.
So think of these as like little pins on the board.
Okay.
That you can configure to either send signals out to control external devices or receive signals in from sensors or other components.
All right.
And through Pete, you can control the direction of these pins, whether they're acting as inputs or outputs, and you can read the current state of an input pin. Or set the state of an output pin.
Right, so it's like a programmable button and light on a simple electronic device.
If a pin will send a signal, like pressing a button, or receive one, like a sensor.
Got it.
Detecting something.
That makes it a lot more clear.
Right.
So could you give a simple practical example of how you might use this?
Okay, so let's say you have a custom solder board. Connected to your Portwell system. And it has an LED. You could use PET to configure a specific GPIO pin as an output. And then you can write a signal to that pin to turn the LED on. Or off.
Got it.
So you're controlling an external LED.
So I could like blink an LED using this.
Exactly.
Very cool.
And conversely, you could also use it to read input.
Right.
So if that daughter board has a sensor, you can configure a GPIO pin as an input. And read the state of that pin. To determine the sensor's reading.
Cool.
So maybe a door is open or closed.
Got it.
You can use PETNI to see if the door is open or closed.
So lots of practical applications there.
Yeah, a lot of possibilities.
What's next on our list?
So then we have the watchdog timer, or WDT. This is a really critical feature for a lot of embedded systems.
Especially those that have to operate reliably.
Reliably in unattended environments.
Yeah. So how does PT let you interact with that?
So a watchdog timer
is like a supervisor for your system.
And
it's designed to prevent the system from getting stuck.
From hanging.
Or becoming unresponsive.
Exactly.
If the main program doesn't periodically kick the timer. Or reset it. The timer will expire and automatically trigger a system reset.
Got it.
So PP provides functions that allow you to check if a WDT is present. Find out its available timer ranges. Set the timeout period. Trigger a reset for testing purposes.
Got it.
And even disable the WDT if you need to.
So you have granular control over that.
You have a lot of control.
That's important.
It is very important.
The next one is hardware monitor, or HWM. What kind of control and information?
So this is all about keeping tabs on the system's health.
Okay.
So PT provides functions to monitor various parameters.
Right.
Things like temperatures, fan speeds, voltage levels.
So like a diagnostic dashboard.
Yeah, exactly.
For the hardware?
Yeah, you can see what's going on.
And can you do more than just monitor?
Yeah, you can. So for example, you can manually set the speed of fans.
Oh, okay.
And there's also support for smart fan control. Where the system automatically adjusts fan speeds.
Based on temperature.
Based on the temperature.
So if things are getting too hot,
right,
the fans will spin up faster.
That's right.
To keep things cool.
That's cool.
And interestingly, they also have functions for generating sound.
Yeah.
So like a beep.
Yeah, like a beep.
Metronome, musical notes.
If you want to play a little song.
That's pretty cool.
Yeah.
So moving on, we have SMBus.
Okay.
Now, we touched on this earlier.
We did.
When we were talking about version history.
Right.
What does PET let you do with the system management bus?
So SMBus is a low-speed two-wire protocol. That's used for communicating with power-related and other low-bandwidth devices within a system.
Got it.
So Pete provides functions to detect if SMBus is available. And if it is, you can send and receive data. You can read and write bytes. You can do process call commands, which are a combined write and read operation. And even transfer blocks of data.
All right, so this gives you the ability to interact with devices?
Yes, with compatible peripherals.
That are connected?
To the SMBus.
To the SMBus.
That's right.
Now, the documentation does have a little note of caution here.
It does.
Basically saying that you should use these functions.
Right.
Primarily if you have added your own devices to the bus.
Right.
Why is that?
Yeah, so the addresses of the built-in SMBus devices on the Portwell board can change depending on the configuration.
So if I try to use this to talk to something
right,
that Portwell put on the board,
you could run into problems.
Okay, got it.
So use this for your own custom hardware.
For your own expansions.
Yes, that you got it.
All right, next up is backlight control.
Okay.
So if the board has an integrated display,
Right.
what can you do here?
You can adjust the brightness of the backlight programmatically.
So make it brighter or dimmer?
Exactly.
As needed.
As needed.
Okay.
But it is dependent on the specific board.
Right. Not all boards will have this.
Exactly.
Okay.
So you got to check the documentation.
Then we have basic I/O access.
Okay.
This sounds like a very direct line.
It is very low level.
To the hardware. What does PCETA let you do here?
So you can directly read and write data.
Okay.
To specific hardware registers using their memory addresses.
So this is like very, very low level.
This is as low as it gets.
Okay.
Very powerful.
Yeah.
But very dangerous.
Okay.
If you write the wrong value to the wrong register, you can crash the system.
Okay, so be careful with caution.
Yes.
Next up is EC I2C. No, we talked about I2C earlier.
We did.
How does this differ from SMBus?
So I2C stands for Inter-Integrated Circuit.
Okay.
It's another two-wire protocol, similar to SMBus.
Right.
But it can operate at higher speeds.
Okay.
And I2C specifically refers to communication.
Yeah.
That's handled through the embedded controller.
Okay, so it's I2C, but
it's going through the EC.
Through the EC.
Right.
Got it.
So you can set the frequency.
Okay.
You can read and write data.
Okay.
And you can do quick read and write operations.
And this is useful for talking to specific...
specific onboard components.
Managed by the EC.
Managed by the EC.
Got it.
Things like sensors.
Okay.
Or other peripherals.
Okay, cool.
And then finally we have...
LED control.
LED control.
And LAN bypass.
So
let's start with LED control.
Yeah, that's a simple one.
Yeah, it's pretty straightforward.
What can we do here?
So you can query the status of the LEDs.
See if they're on or off.
Right.
And then you can programmatically
set them
on or off.
On or off.
As needed.
So if I want to like blink an LED, I could do that.
You could do that.
Okay, cool.
Pretty simple.
And then last but not least, LAN bypass.
Okay.
What is this?
So LAN bypass is a really important feature for network appliances.
Okay.
So these are systems where you need continuous connectivity.
Right. It can't go down.
It cannot go down.
Okay.
So it basically provides a mechanism for network traffic to keep flowing.
Yeah.
Even if the system is off.
Okay.
Or experiences a failure.
There's like a backup.
Yeah, it's a bypass.
Okay.
So the traffic can still go through.
Got it.
Even if the system is down.
Okay.
And PT gives you functions to configure and query the bypass mode.
So you can set it to activate?
You can set it to activate.
When the system powers on or off?
On, power off.
Configure it to engage on the next boot. Or even link it to the watchdog timer.
You can link it to the watchdog timer.
So if the system becomes unresponsive,
right,
LAN bypass kicks in.
That's right.
Cool.
And you can also configure the timeout duration of the watchdog in relation to the bypass.
Got it.
So you have a lot of control.
Lots of options.
Yeah, a lot of options.
Now, in addition to all this core functionality that's provided by the code libraries, the documentation makes frequent mention of the Portwell engineering tool utility.
Right.
What is that?
So the PEAT utility is a standalone software application that provides a graphical interface for interacting with the hardware.
So it's a GUI.
It's a GUI. It's a visual front end.
Got it.
Built on top of the same API functions.
That we've been talking about.
Okay. So you don't have to write code.
Right.
You can just use the GUI to do a lot of the same tasks.
And it works on different operating systems.
Yeah, it's cross-platform.
Okay.
So Windows and Linux.
Right.
Very convenient.
And it's a separate program, right?
Yeah. It's updated.
So I don't need to have like a full...
You don't need a development
environment set up.
Exactly. You can just run the utility.
So what kind of things can you actually do with this utility?
So it mirrors a lot of the functionality of the code libraries.
Okay.
But in a more visual way.
Okay.
So you have things like a system information display.
Okay.
That shows you the platform name, BIOS version, EC version.
Right.
You have a GPIO control panel where you can monitor and toggle the pins.
Okay.
You have a WDT configuration page where you can set the timer range and all that.
Got it.
You have a hardware monitor section that shows you real-time data on temperatures, fan speeds, voltages.
Right.
And you can even configure alarms.
Oh, cool.
And then there's an SMBus interface.
Okay.
Where you can read and write bytes to devices.
So it's pretty powerful.
Yeah, it's very powerful.
Even though it's a GUI.
Even though it's a GUI.
Cool.
Yeah.
So now let's talk about getting started with Pete.
All right.
So what operating systems does it support?
So it supports a good range of modern operating systems.
Yes.
So Windows 10, 32-bit, and 64-bit.
Okay.
Windows 11. And several Linux distros like Ubuntu and CentOS.
Cool.
So that's pretty good compatibility.
That's great.
Yeah.
And what about installation?
Okay, so for Windows, it looks like the driver can be installed automatically.
Oh, cool.
When your application calls the Pete API init function.
Okay.
And then there's a corresponding Pete API unit function that you should call at the end to release the driver resources.
Got it.
For Linux.
Yeah.
It provides static and dynamic libraries.
Okay.
So if you're using the static library, you include the provided header files in your project. Okay. And then compile everything together.
Got it.
If you're using the dynamic library, you would typically install it into your system's library directory.
Okay.
Using a make install command.
Got it.
So that creates a shared library.
Okay.
That your application can link against.
All right, so different options there.
Yeah, different options.
Depending on
you need.
how you want to do things.
Exactly.
Now, the documentation has a section on anticipatory knowledge.
Okay.
What are some of the key concepts here?
So this is a really nice section.
Yeah.
That's aimed at helping users who are new to embedded systems.
Okay.
So they provide concise explanations of some core concepts.
Got it.
So things like the watchdog timer.
Right.
GPIO. SMBus, hell, it's